Hey everyone, today we are going to talk about proving parallels. A shape is a parallelogram. So yesterday we used parallelogram properties to prove other things. Today we're going to talk about how we would prove a shape is a parallelogram. So you can prove a shape is a parallelogram 5 ways. First, you need to show that both pairs of opposite sides are parallel. Then it's a parallelogram. Or I can show both pairs of opposite sides are congruent, then it's a parallelogram. Or I can show both pairs of opposite side angles are congruent, then it's a parallelogram. I can show the diagonals bisect each other, then it has to be a parallelogram. Or if one pair of opposite sides are parallel and congruent, then it's a parallelogram. So now we're going to look at these examples and decide if this is enough information to say that this shape is a parallelogram, that SMTP is a parallelogram. So the first thing they're telling me is SPX is congruent to TMX. So I labeled that wrong, sorry. SPX is congruent to TMX, and that TPX is congruent to SMX. And in fact, that is enough information because I can use the first pair of angles to say that SP is parallel to TM. And I can use the second pair of angles to say that SM is parallel to TP. So yes, because that would give me choice number 1 up there, which if both pairs of opposite sides are parallel, then it's parallelogram. So number 2 is using that same diagram over there, so I'm going to switch colors, is that SX is congruent to XT and SM is congruent to PT. Well, that's not enough. That's telling me that one diagonal bisects the other one, and that one pair of sides, opposite sides, is congruent. So that is not enough. So now I'm going to erase the red because I'm going to erase this all over here on my diagram. It's hard to understand when we're looking at lots of things. Go back to blue. So now I know PX is congruent to MX and SX is congruent to TX. So that yes is enough because I know the diagonals bisect each other. So that's statement number 4 up top there. So then for number 4, I know that SP is congruent to MT, and I know SP is parallel to MT. So yes, again, that is enough because I have one pair of opposite, congruent, and parallel. So that's number 5 up top there. So now I want you to look at these 7 through 14, and I want you to decide whether it is definitely a parallelogram. I know they all look like parallelograms, but I want you to decide if they are definitely a parallelogram, and then come back and check. So number 7 is yes, because that indicates that the diagonals bisect each other. Number 8, that's not enough information. Number 9, that's not enough information. 10, yes, because I have 2 pairs of opposite congruent sides. 11, yes, because that indicates that there are 2 pairs of parallel sides because using alternate interior angles. 12, no. 13, yes, there's 1 pair of opposite congruent and parallel sides. And 14 is no. So now we're going to try to do a proof. So I am given that I have this quadrilateral PQRS, and I know that angle 1 is congruent to angle 2, and I know that angle 3 is congruent to angle 4. So how can I use this information to prove this is a parallelogram? Well, if I look at this diagram, I know that QS is part of both my angle pairs. It's part of angle 1 and it's part of angle 2. Well, when I look at that, I see that angle 1 is also on PS and angle 2 is also on QR. So angle 1 being congruent to angle 2 means that PS is parallel to QR because the angles have to touch the transversal and the side that I'm saying is parallel. Then if I look at the red, which is angle 4 and angle 3, those two have the same transversal of SQ, but those two indicate that PQ is parallel to SR. And so that's because alternate interior angles congruent implies parallel lines. And then knowing that's parallel lines, I can say PQRS is a parallelogram because I have two pairs opposite parallel sides. So proof number 2. So this time I want you to pause and I want you to try to do the proof yourself and then come back. So hopefully you paused and you tried this yourself. Okay, so here's my proof for number 2. So I started off by saying CD and AB are parallel, are congruent, because in a parallelogram, opposite sides are congruent. I then said CD and AB are parallel because in a parallelogram, opposite sides are parallel. Now that piece of information was helpful because that does also tell me that EB and DF are parallel because parts of parallel lines are parallel. So I don't need to include that. I need to keep that in mind. So then because I really want EB is congruent to DF, I can subtract my property from parallelograms and my given. So I can say AB minus AE equals CD minus CF, that's subtraction. Substitution, EB is congruent to DF. And then I know that I have a parallelogram because a parallelogram with one pair of opposite sides congruent parallel. So we now have two theorems that we need to add. I forgot to write is a parallelogram. So our two theorems is number 1, if a parallelogram has one right angle, then it has 4 right angles. My second theorem that I need to say is if 3 or more parallel lines cut off congruent segments on one transversal, then congruent segments on every transversal. So our diagram there is these 3 parallel lines. If it cuts one transversal so that these 2 segments are congruent, every other transversal through those lines will be broken into congruent segments. So that's the end of our video for today. If you have any questions, let me know.